My name is Oktay. Welcome to today's video about noble gases. These are the noble gases: helium, neon, argon, krypton, xenon, and the radioactive radon. This is where the noble gases are in the periodic table at the right side. And one thing they have in common: all noble gases have a full shell of electrons. This is a diagram of the first ionization energy, and you can see in each period the noble gases are at the top. The first ionization energy is the energy that you need to separate the first electron from an atom. This is a picture of the composition of gases in air. Main components of air are nitrogen, N2, oxygen, O2, and among the noble gases, the most abundant is argon with almost 1%. All other noble gases are just in traces in the air. Helium in a gas discharge tube gives you a pink-orange light. The name helium comes from Greek, helios, which means sun. Atomic number is 2, and there are 2 isotopes, and the most abundant is the helium-4 isotope. 1/4 of all atoms in the universe are helium atoms, and the natural gas contains 7% helium, which can be isolated with fractional distillation. This is how the helium is made in the sun. There are 2 nuclear reactions. The reaction at the left is the more efficient one. It's the proton-proton chain reaction. You have 4 protons. That's a multi-step reaction, and in the end you get 1 helium atom, a helium nucleus, and you get back 2 protons, and they can again react in this chain reaction. On the right side you have the CNO cycle. Again you have 4 hydrogen nuclei, protons, and after 1 cycle you get back a 1 helium-4 isotope. This helium-4 isotope is special, as you can see in this picture, of the average binding energy per nucleon. Iron 56 is at the top, and helium-4 is at a local maximum. There is another maximum at carbon 12 and 16. And obviously, the isotopes with an even number of protons and neutrons are a bit more stable. Helium-4 isotope is also the alpha particle. Many radioactive isotopes emit alpha particles. For example, uranium-238. It decays to 234 thorium, and helium-4. Its half-life is 4.5 billion years. This is one of the applications of helium. It's used for cooling of the superconducting magnets in MRI, and helium is also used as a protective gas. Helium-4 at a temperature of below 2.2 Kelvin is superfluid. It's a fluid without viscosity. The right picture you can see if it automatically creeps over the walls and until all levels are equal. Helium is also used for gas tungsten arc welding, for example of stainless steel, as a protective gas. This is the solar ship. It's a helium-filled flying wing solar electric airplane. Helium is also used as a carrier in gas chromatography. In this picture you can see the difference between nonane and decane. Decane is a bigger molecule. It travels slower than nonane. And this is important for forensic science, for example, for investigation of crimes. Neon in a gas discharge tube gives you a red color. Its name comes from Greek neos, which means new. Atomic number is 10. There are 3 isotopes. the most abundant of which is neon-20. And neon is the 5th most abundant element in the universe, but in air it's just at a concentration of 18 parts per million. It was discovered in 1898 by Sir William Ramsay and Morris Travers. You can isolate neon by cryogenic air separation. And this is how the neon was made, by carbon burning in massive stars. 2 carbon-12 isotopes merge to neon-20 and byproduct helium-4. This is a picture of a neon sign in Hong Kong. These are street signs in Kabukicho in Tokyo. This is the helium neon laser. It gives you a red light with 633 nanometer wavelength. It was used as a barcode scanner until it was replaced by the laser diode. Argon gas in a discharge tube gives you this violet color. Its name comes from the Greek word for lazy, inactive. Atomic number is 18. There are 3 isotopes. The most abundant is Argon 40. It is isolated by fractional distillation of liquid air, and the biggest exporter is Germany with 63 million cubic meters in 2020. This is a picture of the nuclear reactions. At the top, the formation of helium-4. Top right, the formation of the carbon isotopes, nitrogen, oxygen isotopes. Here's the helium burning process that gives you the carbon-12 isotope. And at the bottom is the alpha process that gives you all these elements with even atomic number. And since helium-4 is so abundant, that's why the elements with even atomic number are generally more abundant than the ones with odd atomic number. There's a difference between the stellar argon and the terrestrial argon. Terrestrial argon is Argon 40, which is made of potassium 40 by electron capture. And the stellar argon is Argon 36, which comes from this alpha process. These are applications of argon. It is used as an inert gas in the laboratory and industry, for example, for welding. The advantage of argon is its higher mass compared to nitrogen molecule and oxygen molecule. So the argon gas can drive out the nitrogen oxygen from this apparatus. And liquid argon is used for the search of dark matter. There's one candidate that's WIMPs. They are called weakly interacting Mars particles. And argon can also be used as a fruit preservative. This is the argon ion laser. This was invented in 1964 by William Bridges, and it is used in the retinal light therapy. Krypton gas gives you a discharge tube with a lavender color. Its word comes from a Greek word kryptos, which means hidden. Atomic number is 36. It was discovered in 1889. There are 6 isotopes in nature, the most abundant of which is the isotope 84. But the concentration is just 1 parts per million in air, and it is isolated by fractional distillation. This is an example of Krypton. It is filling gas for lamps. This gives you a higher light yield. And the Krypton fluoride laser gives you a UV light with 248 nanometer wavelengths. This is a picture of the SpaceX Starlink satellites. They use Krypton-fueled all thrusters. This is a ionic drive. The element xenon gives you a blue color in a gas discharge tube. Its word comes from the Greek, which is Xenon, which means a stranger guest. Atomic number is 54, and it was discovered in 1898. There are 9 isotopes in nature. The most abundant are 129, 131, and 132 xenon. Its concentration is just 0.09 parts per million in air, and it is isolated by fractional distillation. These are the applications of xenon. Xenon 2 dimer is used for excimer laser, and xenon gas is used as an anesthetic. These are the xenon headlights of the VW Golf. And this is a picture of the spacecraft Deep Space One, which used a xenon ion drive for electric propulsion. This drive gives you just a very weak thrust, but it's a continuous thrust. And over time, the Deep Space One reached a very high velocity. This is a picture of the uranium-238 decay chain. It's one of its products is element radon with atomic number 86. It was discovered in 1899. There are 39 radioactive isotopes, the most stable of which is the 222 with a half-life of 3.8 days. And radon is dangerous, hazardous, and carcinogen because it is an alpha particle emitter. The alpha particles cannot even penetrate a piece of paper, but when they get in the body, then they are very dangerous because the alpha particle has two positive charges and is highly ionizing. This is a nice example of how you can develop a concept in chemistry. If you want to make noble gas compounds, there is a known compound as oxygen difluoride, OF2. And oxygen is in this diagram of the ionization energies, 2 positions to the left of neon here. So obviously fluorine is the best reaction partner for making compounds because it has the highest electronegativity with about 4.0 at the Pauling scale. And if you want to make compounds with fluorine, which of these noble gases should you pick? And the answer is in this diagram. You pick the noble gases that have the same ionization energy as oxygen or a bit lower. And that's Krypton and Xenon. Here are a few examples of these compounds. At the top left, Krypton difluoride with its linear structure. At the top right, Xenon tetrafluoride with planar structure. At the bottom left, Xenon hexafluoride. It looks like an octahedron, but it's an irregular octahedron because the xenon has 6 bonds to the fluorine atoms. Thus, it has a 3 electron pair. At the bottom right, that's xenon trioxide. It has a tetrahedron structure. The xenon sits in the center, and 1 free electron pair points to one of the corners, and the other 3 corners are occupied by the oxygen atoms. The first noble gas compound was synthesized in 1962, and all these compounds are strong oxidants. This is the molecule cation argonium, ARH+. It was detected in the Crab Nebula. This is the molecule cation helium hydride, HEH+, was detected in the Jubal-Back Nebula, NGC 7027. And this is an important molecule because this helium hydride was the first molecule in the universe after the Big Bang. After the Big Bang, the temperatures and the radiation was too high for normal molecules, like for example H2, but not too high for this helium hydride molecule. That's why this is interesting and fascinating. That was today's video about the noble gas chemistry. Thank you for watching. Have a nice day. Bye bye.